Hi, this is Victor Morganti from Fact Engine. Today we're going to look at creating a entity relationship diagram in the Boston conceptual modeling software from end to end. So we're inside Boston here at the moment, and Boston is conceptual modeling software created by Fact Engine, and where Fact Engine is also a query engine which runs over models over the top of databases where you create those conceptual models inside Boston. So Boston is available as a Windows software or through your web browser in the cloud, or you can host Boston on premises or via your intranet or extranet, where users can do conceptual modeling concurrently and collaboratively through their web browser. So we've got a model explorer on the left hand side in Boston, and I've got a model already open in the model explorer. Models are broken down into pages, and this particular model is for a conceptual model for a database for cinema bookings. So a little bit of attribution. The original model this was derived from was developed by Data Constellation and shared on GitHub. So as a cinema bookings conceptual model, the model stores information about people who make bookings for seats, where the booking is for a session to watch a film at a cinema, and where seats are in rows in cinema and seats are in sections. So you'll be very familiar with going to the cinema, and not everyone does it, but some people will make bookings. They actually book a seat in advance to watch a film at a session at a cinema. So that's what the conceptual model is. We know in Boston that we can view our conceptual model as a property graph schema, where this becomes a property graph schema if I control click on a node type and see its properties. So booking has these properties: person ID, film ID, date, time, cinema, and the seat count, for instance. And excuse me. And a seat has a cinema ID that the seat is in. It's the row number of the seat, so row number 10, for instance, and letter A, B, C. So we can talk about row 10, letter B. Identifies a seat, and the section name of the section that the seat is in. In Boston, we can view our model as a property graph schema, or we can view its corresponding entity relationship diagram where there is one, and this is the same conceptual model but as a entity relationship diagram. So person, booking, session, film, cinema, row, seat, section. But we've got this many-to-many table between booking and seat, which we don't see in the property graph schema. If I'm not mistaken, I should be able to morph back to our property graph schema, and that'll get absorbed absorbed back into the many-to-many relationship. So this many-to-many relationship between booking and seat. So in Boston, we can also view the model as an object role model, and this is exactly the same schema but as a object role model, this is quite a busy object role model, but we have person, booking, seat, row, cinema, session, and section. So every model in Boston is ultimately a object role model, and we have ostensible views of that object role model as a entity relationship diagram or a property graph schema, and where databases are coming to be known as being able to be viewed as a relational knowledge graph. So that's the reference schema that we'll be looking to recreate today as an entity relationship diagram in Boston. And if I go to Fact Engine, we can ask questions, for instance, which film is showing at the cinema, Great Western Cinema, on which date, time. So that's our definition of a session. So which film is showing at the Great Western Cinema at which date, time. This particular model is hooked up to a database. We can go on that and we can see that Rocky, Grease, Dr. Zhivago are showing at the Great Western Cinema at these dates and times. So that's our ultimate goal, of course, is to be able to store information within our database and to be able to query our database. Here's the SQL query that's converted from Fact Engine query language to get our results. So let's go ahead and create our entity relationship diagram. We're going to recreate the cinema bookings model. There's three ways to create a model in Boston. You can click on this button here to create a new model. You can right click on models and add model, or you can say session, new model. So I'm just going to click on this button here. And create a new model. I'm going to rename that model straight away. I'm going to call that Cinema Bookings 2 and save that. So it's already got a page, but that's an object role model page. Let's create a entity relationship diagram page in our model and open that. So on the right hand side we've got a toolbox, a model dictionary and a properties grid. So we can just use the toolbox. So we're going to drag an entity over from the toolbox. And we're going to give that a name using the properties grid. And so we're going to create cinema. So we want to watch movies in a cinema, so we need a cinema entity type. Now in Boston, to create a single column primary key, we use reference mode, and I'm just going to give cinema a reference mode of ID. Now what that's going to do is create a single column cinema ID with a hash against it to show that it's our primary key. Now let's give cinema a name. So I'm going to add an attribute to our entity, and I'm going to call that cinema name. I'm going to give that text fixed length. I'm going to say it's mandatory, and I'm going to say length 200. So we've just given cinema a unique primary key, cinema ID, and a cinema name. What we're going to do is create a unique index on cinema name. I'm going to apply that so we can see that we've got the primary key as cinema ID, but we're going to create a unique index on the cinema name so that we can refer to cinemas by their name uniquely. So I'm going to close out of there, and we're going to do something a little bit tricky now. We're going to go to the model configuration for our first model and grab the connection string for the SQLite database behind the model and copy that over to our new model. So I'll just test the connection. That's successful. I'm going to apply that, and now if we go back to Fact Engine and type which cinema, I should be able to automatically now start querying our database. So we can see we've got the Great Western Cinema, the Northern Star Cinema, Watson Cinema, and the Rialto. So as we create our entity relationship diagram, we can actually query the model as well. So I'll try and speed things up a little bit now. So let's go back to the toolbox. We're going to create a new entity type. and call that film. And again, we're going to give film a reference mode of ID so that we have a primary key of film ID. I'm going to give film a name column. Normally I'd say film name, but I know the database just has name, so we'll use name. I'm going to say text fixed length is mandatory. I'll use 200 for the column length because you can have quite long names for films. So I'm going to hit OK on that, and we've got film ID as the primary key. We've got a column called name. Now I'm going to create a unique index on name so that we can uniquely identify films by their name as well. Again, we should be able to go to Fact Engine and say which film. So we've got Dr. Zhivago, Grease, Inception, Rocky and Speed as the films in our database. So we've got cinemas, we've got films. We need rows and seats, so let's create those. At this stage I'm just going to leave row without a reference mode, and we're going to do the same for seat. And we know in our database we have sections, so let's create a section, and I'm going to give section a reference mode of .name so that it has a unique primary key of section name. Now, unless I'm mistaken, I should be able to just say which section in Fact Engine, and we've got the public, gala and deluxe sections in our database. Now let's start to hash out some columns for row and seat. Now if I drag from row to cinema, it's created a relation between row and cinema, whereas cinema has many rows. There's our crow's foot there, and a row is in a cinema. We've got a cinema ID referring to the primary key of cinema, and the message that came up said that we should create a primary key for row as soon as possible. We'll do that, but after we create another attribute column or field for row, and we're going to call that row number. I'm going to give that a data type of numeric unsigned small integer. I'm going to say it's mandatory. So a row has a cinema ID and a row number. Let's create a unique primary key index for row. So I'm going to call the index row PK. I'm going to set it as the primary key, and it's going to be across cinema ID and row number. I'm going to apply that, and that's pretty much row set up. So if I go to our Fact Engine and say which row, we'll see in our database we've got a whole bunch of cinema and row combinations in our database. So cinema 1 row 1, cinema 1 row 2, cinema 1 row 3, etc. Now let's do the same thing for seat. Let's drag from seat to row, and it's saying you should create a primary key as soon as possible. We will. We now have cinema ID and row number as reference columns in our entity, and where the relation points to row, and where a row has many seats and a seat is in a row. To To complete the primary key, we'll give seat a letter, and we're going to say that a letter on our seat is mandatory and it's a length of 1. So we can be in row 10, seat letter D. So Cinema 1, row 10, seat D, for instance. So we now have Cinema ID, row number and letter. Let's create a unique primary key for seat. So its type is primary and it's across Cinema ID, row number and letter. And we're going to apply that, and we're going to create a relation between seat and section. So we're going to say a seat is in a section. So unless I'm mistaken, we should be able to just go which seat in Fact Engine and have a look at the various seats that are in the database. So Cinema 1, row number 1, letter A, Cinema 1, row number 1, letter B, etc. So these are all the seats that have been set up in the database. And I should also be able to view the table data as if we were using something like Microsoft Access. So in the database table data toolbox, I can see and edit data in each table. So I can see for seat, Cinema ID, row number, letter and the section name, and I can edit any of these data directly from inside Boston. Okay, so we've got cinemas, we've got rows, seats, we need people. So let's set up a person entity type. I believe person has a unique primary key of person ID, and I believe in our database each person is uniquely identified by their login name. So we'll give each person a login name, so you can imagine where people are logging into a website, for instance, to create a booking at the cinema, and we'll give that a length of 100 just for our purposes. So let's hit OK on that, and login name should be a unique index, so let's apply that, and if I'm right, we should be able to view the table data, and there we are. So we've got 4 people in our database, persons 1, 2, 3 and 4 by person ID, and logins names Peter, Paul, Mary and Simon. Right, so let's set up a session entity. So we go to the cinema to watch a film at a session, and what we're going to do is we're going to drag a relation between session and cinema. Yes, we will create a primary key as soon as possible. I'm going to drag a relation between session and film. And we know that a session is at a particular date time. I'm going to select the data type of temporal date and time. We're going to say it's mandatory. Now we'll set up the unique index across the primary key index across Cinema ID, Film ID and date time. I'm going to apply that, and we're going to do something special here. We're going to click on session, and we're going to say convert to a fact type. Now that's going to, at the object role model level, convert that ostensible entity type to a fact type, and we'll see the reasons why in a second. So if everything's gone well, I should be able to go to the reading editor, and now we can set up something special for session. We can say cinema is showing film at date time. So that's a reading for session. So cinema is showing film at date time. We can set up another reading for session. We can say film is showing at cinema at date time. And hit enter on that, and we're not going to change the name of our fact type. So there's just 2 readings of possibly up to about 9 different readings, I believe, you can get from a combination of 3 columns for session. Now if I go to session and look at the table data, we can see our films and date times and cinemas. If we go to Fact Engine, we can say which film is showing at which cinema at which date time. We can see that Rocky is showing at the Great Western Cinema at this particular date and time. And we've got one record where Rocky is showing at the Northern Star Cinema, but in our query we can just limit that to the Northern Star Cinema by saying which film is showing at the Northern Star Cinema at which date time, and we can see that Rocky is showing at the Northern Star Cinema at that particular date and time. Great, so we've got film, session, cinemas, rows, seats, sections and people. Let's create bookings. And we're going to create the primary key for booking by dragging a relation to session and a relation to person. And we're going to go to the index manager and create a primary key for booking across cinema, film, date, time and person, and we're going to apply that, and unless I'm mistaken we should be able to view our table data. So where we're looking at film 1 on this particular date is showing it has a booking for cinema 1 with person 1. The seat count here is going to be derived, and we're not going to show that at this stage. So I believe we can say in Fact Engine which person has a booking that is for a session to watch the film Rocky. Now this won't actually work at this stage because we need to do some work, but I'll just leave that query there for a second. The reason why is because we need to set up our readings for these relations. So for instance, booking relates to session. We have to say booking is for session, and we're not going to change the name. And let's have a look at our query again. Session is to watch film. So if we go between session and film and change that from session relates to film to session is to watch film, there's every chance our query will work now. So let's have a look at that again. Which person has a booking? So let's make sure that we have a relation there. Booking is for person. We're not going to change the name, and we're going to say person has booking. So after you've made the booking, you have that booking. Right, let's look at our query again. So which person has a booking that is for a session to watch the film Rocky? We're going to hit go on that, and we've got our results. So Peter has a session at a booking at cinema number 1 to watch the film Rocky, we said in our query, at this particular date time, and the rest of this information returned is superfluous. And if we wanted to know the cinema, I could say at which cinema. I believe that'll work. Let's try at a cinema that has which cinema name. Here we go. So Peter has a booking at this particular date and time to watch Rocky at the Great Western Cinema. He also has a booking on another date to watch Rocky again at the Great Western Cinema. So that's using Fact Engine. Here's our SQL query behind that. That could be Cypher or TypeQL for TypeDB, but this is a SQL database. Right, so we've got people, booking, films, sessions, cinema, rows, seats and sections. We just need now a relationship between booking and seat. Now this one's going to be a bit tricky to set up to match the database, but we'll give it a go. Right. So I know the table name is booking has seat, and we're going to drag a relation between booking has seat and booking, and we're going to drag a relation between booking has seat and seat, and we're going to create a unique index, primary key index, across all of those fields. Apply. Now I know in my database these columns have different names, so just give me one sec while I try and resolve that. If I go and have a look in our original model, we'll see what's what. So cinema ID without an underscore is for booking, and cinema underscore ID is for seat. So let's go back to our model, and cinema, we're going to change the name of that column to cinema ID, and cinema ID 1 we're going to change to cinema ID. Let me try and refresh. Okay, so now I'm looking at the data, and we can see that these particular bookings are for these particular seats. So if I go back to my query and I say, and that booking is for which seat, I need to complete something first. This is now an entity. I need to convert that to a fact type. And once I've converted that, I can go to the ORM reading editor, and we can see that a booking has seat. So I can ask the question, booking has which seat? Right, so we're saying which person has a booking that is for a session to watch the film Rocky at a cinema, that has which cinema name, and that booking has which seat. So I'm going to hit go on that. No such column, booking has seat, cinema ID 1. We've got a bit of a problem there. Right, something didn't register. So this needs to be if I hit save on that, hopefully that'll save the details. Let's rerun the query, and now we've got our result. Okay, so Peter has a booking to watch Rocky at the Great Western Cinema in seat 1A on this particular date and time, and seat 20A at this other date time. And we've finished our entity relationship diagram. So let me just tidy that up a little bit. Put cinema there, put session here, let's put film up here, and maybe drag session there, seat there, row there, and put booking as seat in the middle there. Right, so there's our complete entity relationship diagram. So where people can make bookings for sessions to watch films at cinemas, and the booking has one or more seats, and where a seat is in a row in a cinema, and a seat has a section name. Let's do a little bit of magic now. I'm going to just minimize that. So we're looking at our new model. I'm going to create a property graph schema page from this entity relationship diagram. And unless something goes horribly wrong, we have a property graph schema for our model. This particular property graph schema has put booking has seat as a node rather than an edge type. If I reload it, maybe it might show as a edge type. We can change this to be an edge type. Say if we're working with a Neo4j database, we don't need to have an extra node there. So that's a property graph schema generated from our entity relationship diagram, and we can generate an object role model from our entity relationship diagram. This won't be pretty, but if I tidy it up a little bit, we'll see how long that takes. This might take a little bit to tidy up. I don't think we'll go through the whole process of tidying this up at this stage. But we can see up the top left hand side there, we've got session. So a session is where a film a session is to watch a film at a cinema at a particular date time, and we can see that a booking is for a session, and a booking is for a person. Booking has one or more seats. The seat is in a section. A seat has a letter and is in a row. A row has a row number and is in a cinema. The fact type readings we would need to tidy up. So we're just saying row relates to cinema, but if we go to the fact type and the ORM reading editor, we would tidy that up to say row is in cinema, for instance. Right, so we've seen how to create a entity relationship diagram inside Boston. We can convert that to a property graph schema and an object role model. So the three primary languages within the Boston conceptual modeling software. and I'd like to thank you very much for watching. So if you enjoyed the video, please hit like and subscribe, and I'll see you in the next video.